Let's start with few problems based on oscillations. Okay. Now, let's start with the first one here. Look at the first one. A spring balance has a scale that reads from 0 to 50 kg. The length of the scale is 20 centimeter. A body suspended from this balance, when displaced and released, oscillates with a period of 0.6 seconds. What is the weight of the body? Okay, now here let's write down what is given. Now, the first thing what is given is m value is equal to 50 kg. You have, see, the displacement is 20 centimeter. That means y value is 20 centimeter. That's 0.2 meter. Then the next thing what is given, spring balance. Okay, it oscillates with a period of 0.6 seconds. So capital T is equal to 0.6 seconds. Now, restoring force F is equal to K into Y, because you need the weight. Weight is mg, correct? So we have to calculate the value of m basically. Now F is equal to Ky. So force m into g is equal to K into Y. So K is equal to mg divided by Y. So if you substitute, you get 50 into 9.8 divided by Y value is how much? 0.2. Okay. So if you solve this one, though this gets cancelled to 49 times. 49 into 50, which gives you 2450 Newton per meter. This is the value of K. Now what we use? Now what we do? Now we are going to take the next formula. That is, we'll take T is equal to 2 pi root m by K. Now m is what is required? Square on both the sides. T square 4 pi square into m by K. Alright. Now make m as the subject of formula here. M is equal to K into T square divided by 4 pi square. K value we know, T value we know. Substitute. This is going to give you, this implies m is equal to, K value is 2450. So 2450 into 0.6 square by 4 into pi square, correct? So you can take 3.14 square. Now if you do this, then m value will be 22.3 kg. Since m is 22.3 kg, now we need the weight, correct? So weight W is equal to mg, which becomes 22.3 into 9.8. So therefore, final answer, therefore W is equal to 218.5 Newton. This is going to be the value of the weight. Okay, this is the first one. Let's solve a couple of more problems based on the same thing. See the next question. Here you have a spring, correct? Look at that. A spring having with a spring constant 1200 Newton per meter is mounted on a horizontal table as shown. Okay. Then a mass of 3 kg is attached to the free end of the spring. The mass is then pulled sideways to a distance of 2 cm and released. Determine frequency of the oscillation, maximum acceleration of the mass, and the maximum speed of the mass. Okay. Now you have 3 things to calculate. Let's write down what is given to you first. Alright. See what is given. K value is given. The spring constant K is equal to 1200 Newton per meter. Next what is given? The mass is given. Mass is 3 kg. Okay. Then what is given? Sideways. So basically the amplitude is equal to 2 centimeter or 2 into 10 power minus 2 meter. This is the amplitude. Now the next part, what is there? Okay, fine. Then they're asking you what is the frequency. Now time period, we know the formula. So frequency is 1 by time period. Correct? So let's solve with the next part here. Okay, so we are trying to calculate what is the frequency. Frequency nu is equal to or f is equal to 1 by t, which is equal to 1 by 2 pi root of k divided by m. This is the formula, correct? Now substitute the values. You have 1 by 2 pi into root of k value is how much? 1200. M value is 3. 400 times. And root of 400 is 20. So you have 1 by 2 pi into 20 or 10 divided by pi. If you take pi as 3.14, that means we have 10 by 3.14. So you can say approximately around 3.2 per second or 3.2 hertz. This is going to be the first part of the question, okay, which is the frequency part. Now the second part of the question what we had, see second part they're asking you the acceleration, correct? Now maximum part. For that what we do, again let's take the acceleration formula. So this is the first part of the question, so this is, let's call it as 1. Second part of the question what you have, the acceleration A is equal to omega square into y, or you can write this as k by m into y. Alright, so this is going to become k value 1200 divided by m, which is 3 into y. Now maximum displacement is basically the amplitude, correct? So y value is going to become the amplitude. Amplitude is what is given, amplitude is 2 into 10 to the power minus 2. So 400, 4 into 10 power 2 into 2 into 10 power minus 2. Answer is going to become 8 meter per second square. This is the value for the acceleration at the maximum amplitude. The third part of the question, see the third part of the question talks about the maximum speed of the mass. Let's solve that one. The maximum speed basically is velocity, right? See, when do you have the maximum velocity? Maximum velocity is at the mean position, correct? At the equilibrium position. See, what you have here is that maximum velocity is going to become a into omega or a into root of k divided by m. Now you substitute. This is going to become 2 into 10 power minus 2 to root of 1200 by 3, 400 times. So 2 into 10 power minus 2 into 20, or you get 0.4 meter per second. Alright, so these are the 3 values of whatever the problem that was given to you. Okay, next set of problems we'll do in the next video.